Ladies and gentlemen, please welcome Duncan Epping and Cormac Hogan.
Well, yeah, thanks very much. We haven't done anything yet, but thanks anyway. I've no idea what that disclaimer is about either, but I don't know, seem to want to.
That's fine.
Say them.
So let's start with an introduction first, because I'm assuming not everyone knows I'm Duncan Epping and he's Cormac Hogan. Just to make it clear, I'm the bald guy, he's the guy with the ponytail, so that hopefully helps a bit. Today we're going to be talking about vSAN and the top 10 things to know about vSAN in particular. Over the past 2 or 3 years, we've done a lot of vSAN sessions, we've been answering a lot of questions. So what Cormac and I did is we looked at all of the different questions that we received, and we created a top 10, and we tried to create a session that explains some of the most common questions that we get out in the field. Cormac and I are both part of the Office of CTO within the Storage and Availability business unit. So talking about vSAN is basically our job role. On top of that, Cormac does a lot of beta and alpha testing. So as I said, today we're going to be talking mainly about things that are already in a product. There may be some future things in there, but it's mostly about what's in the product today and how the product actually works today. So we have a pretty full agenda. We have about, I think, 60-something slides. So there's a lot of slides, but we'll go through them at a fairly rapid pace. So I'm going to start off first, and I'm going to talk about what vSAN essentially is. When I talk to customers, I get a lot of questions around, what is vSAN? What does it look like? How does it actually work? And because vSAN is a distributed system, a lot of people are under the impression that vSAN is a distributed file system as well, and that's actually not the case. If you look at vSAN itself, it's an object store. It's not like an S3 type of solution, but it's still an object store. Now, the key difference between an object-based solution and a distributed file system is the fact that in vSAN's particular case is that every single device that's part of the system is individually formatted with a file system. That also means that if you have a file system corruption of any kind, that file system corruption won't be spread throughout the environment itself. It will be contained to that particular disk. So if you look at this diagram, then I just want to explain one thing, because those are concepts that are typically mentioned during discussions, and that's the component and the object. If you look at the VMDK up there at the top, the virtual disk, this is what we typically refer to as an object. And if you look at the two hosts in this particular picture, you see component 1 and component 2. Those are data components. So you can basically view them as two identical copies of the same file, more or less. Now, I just said file, I probably should say object, because the big difference is in this particular case, it's an object-based storage system, and the way you go about deploying virtual machines is by using policies, and those policy capabilities are associated with those objects. And that's the big difference between file systems and object-based storage solutions. Now, I already mentioned this policy. Is anyone already in the room already using vSAN? Can I see some hands? Okay, quite a number of people. So hopefully most of you have already seen this screen and set up multiple policies in your environment to determine for a virtual machine what the availability should be or what the performance should look like. So for those who haven't used vSAN yet, I would highly encourage you guys to do a lab and play with vSAN a bit, and you will notice instantly that the way you go about deploying virtual machines is probably different than how you deploy virtual machines as it stands today. Right now, when you deploy a virtual machine on a traditional storage system, you go to a spreadsheet, try to figure out which functionality is enabled on which LUN. Then you deploy the virtual machine, and hopefully you pick the right LUN, right? In the case of vSAN, what you end up doing is you create these policies, and those policies, for instance, determine how many copies of the data you have. And as I've already said, we have these components, which are part of that object tree. And in this example, it's all about availability. When we talk about policy, we mainly talk about failures to tolerate. And failures to tolerate determines how many copies of the data will end up on that vSAN data store and are distributed across your cluster. Now, in this particular example, you see 2 copies of the data. So in this case, failures to tolerate was set to 1. If you would set failures to tolerate to 2, you will get 3 copies of the data, and so on. Now, the thing here is, in this particular situation, you have 2 copies of the data, but just imagine there's a split between host 1 and host 2. How do we determine which host gets access to the data? Well, that's where the witness comes into play. So if you start looking at vSAN and you start looking into it a bit more in depth, you look at the file structure or the object structure, you look at the lower level details, you'll start seeing things like witnesses. So and those witnesses come into play when, for instance, a partition or an isolation occurs, and it basically determines which host gains access over the data when a partition or an isolation has occurred. So the witness is very essential when it comes to vSAN. Now, we mentioned that this was going to be a top 10, and the key thing here is telling you guys about things that you don't know yet. And I think this is one of those things that is new that not a lot of people have seen yet. And we get this question fairly often. Okay, you have this witness mechanism, there's a voting mechanism. How can I actually see from the command line or in the UI how many votes each of the components has, so that when there's a partition, I know which partition will gain access? And that's what you can use this ESX CLI command for. So you go to the ESX prompt, you enter the ESX CLI command, debug object list, and it will actually show you for each of the different components who owns what. Now, the other thing that I wanted to briefly discuss, we just mentioned having multiple copies of the data, and in this particular case, you see a RAID 5 configuration with a lot of components. There's actually 11 components per RAID 0 instance. So you have a RAID 5 set and a RAID 0 set with 11 components underneath. So the question is always, okay, how does that happen? Well, it can happen because of a couple different reasons. First of all, you can set something like a stripe size within a policy. So within a policy, you can say, I would like to stripe this particular virtual machine across 8 or 9 physical spindles or SSDs, right? The other option is, for instance, when you have a VMDK, which is extremely large. So if you have a VMDK, which is 64 terabyte or even 2 terabytes, vSAN will start chunking up the data across multiple physical devices. Now, there's a big difference between these two things. If you specify the stripe within policy, what you will see is that vSAN will actually place the data on different physical devices within a disk group. If you look at the picture that I just shown, and you look at the UUIDs, well, what stands out here is that in this particular case, for a certain RAID 0 set, you see the same UUID reoccurring. That also means that in this particular situation, we didn't define a stripe size. In this case, the disk was actually striped because it exceeded that 255 gigs from a capacity perspective. So vSAN striped it itself, and as such, they actually ended up on the same physical devices. So that's how, from a UI perspective, you can actually see that something was striped due to, for instance, the capacity of that particular disk itself. So now I'm going to hand it over to Cormac, and he's going to talk about, again, certain failure scenarios.
I think you're after overrunning, are you?
Yeah, that's fine. We've got a lot of time. It's the end of the day.
There we go. So I'm going to talk about the different failure scenarios. I'm sure you're already aware with vSAN that one of the major parts or the major policy is the ability to tolerate failures. But there's lots of different failures we can have, right? So it could be disk failure or disk group failure, it could be host failure, and so on. So I'm just going to talk about the different configurations that we can have around failures to tolerate. So this is our generic simplest overview, 4-node cluster, and we're using the default policy, which is a RAID 1 mirroring configuration, and this configuration having the ability to tolerate one failure. And so for something like that, we'll end up in a situation where the VM will be deployed on one of the hosts, we'll have our first copy of the data, the second copy of the data, and then as Duncan highlighted, we'd have the witness. So in this particular scenario, we can tolerate a failure on a disk. So that could be the capacity device, or it could be the caching device. It could be the complete disk group, it could be a network, it could be the complete host as well. So this is kind of our generic configuration. Now we have the ability, as Duncan also said, to tolerate more failures, but you would need more hosts in the clusters to do that with a RAID 1 configuration. The kind of drawback with the RAID 1 configuration is you're using multiple copies of the data. So in order to tolerate the maximum of 3 failures, you're going to have 4 copies of the data on your vSAN cluster, which is a lot of capacity that's being consumed. So in a previous version, I think it was 6.2, we introduced erasure coding, which is basically a RAID 5 or a RAID 6 configuration. So RAID 5 will allow us to tolerate one failure, but will consume much less space on a vSAN system. A RAID 6 configuration, that allows us to tolerate 2 failures, and again, consuming much less of a configuration as well. How many of you are using erasure coding RAID 5 or RAID 6? Okay. So the only thing with it, the thing with number of hosts in the cluster is if you're using a RAID 1 policy, you can have a minimum of 3 hosts in the cluster. But if you're using RAID 5, it has a requirement of 4 hosts. And RAID 6, there's a requirement to have 6 hosts. Reason for that, RAID 5 we implement as 3 data segments plus 1 parity segment, and RAID 6 we implement as 4 data segments plus 2 parity segments. And all of those segments need to be on different hosts. Okay, so that's just general setting giving you an overview of what we can do with a typical configuration. If we move on and have a look at another feature that we have with vSAN, it's a feature called fault domains. Now, every host in vSAN is typically its own fault domain. But if you had, let's say, different racks of systems, and you wanted to be able to tolerate a complete rack outage, we have the ability of configuring hosts and placing them in a fault domain group, for want of a better description. So for instance, in this 8-node cluster here, what I've done is I've put 2 of my ESXi hosts that are in the same rack into its own fault domain. And now when I deploy, let's say just using the RAID 1 configuration once more, I could end up with something like this. So my VM would be deployed on a host somewhere, let's say it's in rack 1, and then my copies of the data could be in rack 2 and 3, and my witness could be in the final rack 4. So now if I have a failure in this situation, complete rack could go down, I'm still good. So that's why, if I did not have this fault domain utility available to us, the objects could end up anywhere, or the components could end up anywhere. So it could be that both copies of the data end up on hosts that are in the same rack. But with fault domains, I can avoid that, and I can choose to put hosts into different fault domains, and then when I go and deploy out my VM, my components end up in different racks. Does that make sense? So I can take this one step further now, and I could do a sort of campus cluster configuration using fault domains once again. So this could be 3 different rooms within the same building, could be 3 buildings within the same campus, something like that. And what I would do in this case, once again, is I'm taking the example of having 2 hosts in each room or in each building, and I'm putting them into their own fault domain. So now when I deploy out my virtual machine, because my fault domains have been set up on a per room basis or per building basis, whatever the case may be, now my copies of the data will end up in the different rooms or the different buildings. So this is a kind of interesting one, insofar as you don't need stretch cluster to implement something like this. This can be just done with the standard vSAN licensing. And we have quite a few customers doing that, right? Some very big customers who have implemented vSAN in this way without stretch cluster, but still getting this resilience of across rooms or across buildings. Okay? There is one caveat, and you might notice that we've called it out, is the requirement on the RTT, the round trip time. There's a requirement to have 1 millisecond between the different rooms or the different buildings. The stretch cluster allows us to go up to 5 milliseconds. So if you have that RTT time between buildings, that's greater than 1 millisecond, you are going to have to consider something like a stretch cluster to implement availability. But if you have this 1 millisecond RTT between the different buildings or rooms or sites, whatever the case may be, you can actually set up a campus cluster like I've shown you here. All right. So the final thing I wanted to call out is in vSAN 6.6, which is our most recent, well, our second to one most recent release, we implemented and this is stretch clusters now, we've implemented a second failures to tolerate mechanism. So prior to this release, stretch cluster, we only had a single mirroring availability, or single copy of the data, one copy on site A and a second copy on site B. So if we lost site A, All our VMs would run on site B, but the thing is they'd be only running on a single copy of the data. There was no local site protection. So what we've done in 6.6 now, we've introduced this second failures to tolerate, where we still have the RAID 1 primary failures to tolerate across the sites, but we can implement a RAID 1 or a RAID 5 or a RAID 6 on each of the different sites. So now even if we lost a complete site, we still have the ability to tolerate maybe another host failure or disk failure or whatever the case may be on the remaining site. All right? Yeah. So I think that's pretty much it. The last thing I wanted to highlight on this slide is we also have the ability to have VMs that don't need to tolerate any failures across site. So in other words, we could have the primary failures to tolerate set to 0. So there's only a single instance of the VM implemented, no second copy of the VM. But we could use the secondary failures to tolerate to give it a RAID 5 or a RAID 6 or a RAID 1 within the same site. So this just means then that if you had an application that maybe the application was available on the other site already, you didn't need to actually mirror that application or mirror that VM. You could implement this with a primary failures to tolerate of 0 and then use secondary failures to tolerate to give it some availability on its own site. Okay, so you're going to...
Yes.
About this. Not going to go through all of this. All these slide decks become available to you at the end of the, I guess, VMworld or whatever. So this is just their kind of table, educational table, if you will. So it just defines all the different availability options that you have available, number of hosts that you need, and so on.
Yeah, so far we primarily spoken about which features are policy driven, but of course there's also features which are not policy driven. So within vSAN, as I already mentioned, you have that policy interface, and you define availability and other things. There's also a couple of features that are not, as I said, policy driven. The two that most people end up using are deduplication and compression and encryption. So I'm going to talk about deduplication and encryption a bit more in depth. It's not going to be a deep dive. For anyone interested in the deep dive, John Nicholson is actually doing a deep dive that includes deduplication and compression and encryption. So he's going to talk about that for about 60 minutes. And this is probably one of the slides you will end up seeing that particular deck as well. Now, is anyone in the room using deduplication and compression? So, okay, that's quite a big number. For those who are not using deduplication or compression or are interested in using deduplication and compression, the big difference between how we've implemented it and how most other people have actually implemented it is the fact that we do deduplication and compression near line. So that basically means that as soon as a virtual machine writes to the vSAN data store, that write will be absorbed within the vSAN cache itself. As soon as the cache starts destaging the I/O to the capacity layer within that particular disk group that you have created or have set up, at that point in time, the deduplication and compression will happen. So it won't happen in line, but it will happen near line after the write itself has already been absorbed into the system. The big benefit, of course, of that is that you have no latency in terms of the deduplication actually happening at that particular point in time. I want to point out here is that if you do have deduplication and compression enabled, and you have, for instance, a database running and it doesn't really compress too well, vSAN will actually detect that. So if you're writing 4K blocks down and the compression, for instance, ends up to like 3 KB or maybe close to 4, then at that point in time, we won't write that particular block compressed. The key reason for that being is that decompressing that particular block would be more expensive than the space we would be saving. So only if the block ends up being 2 KB or smaller, we will actually end up storing it in a compressed manner. So that's deduplication and compression. We also announced vSAN data at rest encryption. Now, some of you may wonder why we did this, because we also have vSphere encryption, which was released in vSphere 6.5. Now, vSphere encryption is a great solution and works based on policy-based management, but the downside of it is that it doesn't take any of the vSAN data services into account. So it doesn't take deduplication and compression into account. So that also means that when you write a block down using VM encryption, that it comes, or it arrives at the vSAN layer in a fully encrypted manner, and it kind of looks like a random block. So you won't be able to deduplicate it, and compression is also highly unlikely. So that's why we created vSAN data at rest encryption. What we do in this particular case, when a virtual machine writes, is we will actually write that particular block in cache in an encrypted manner. Then as soon as we need to destage it and deduplication and compression will need to happen, we will decrypt that particular block, deduplicate it or compress it, encrypt it again, and store it on top of the data store. Now the big difference between these two, as I already said, is the fact that vSAN takes those data services into account, but on the other hand, the data itself doesn't travel encrypted in the vSAN case, it does travel encrypted in the vSphere encryption case. So depending on your requirements, you could pick either of the two. Then there's one other thing that I wanted to briefly mention. Swap files. Now, most of you are hopefully aware of what a swap file is, right? If you create a virtual machine, you will have a swap file locally. In the case you're running out of memory and you're overcommitted, what the hypervisor will do, it will actually start allocating blocks from that particular swap file to that particular virtual machine, and now you're actually using storage as memory. Now, the thing with vSAN is, if you create a virtual machine and that virtual machine has 16 gigs worth of memory or 8 gigs worth of memory, what will happen is that we will create an 8 gig swap file, and that particular swap file is reserved. Now, as you remember, we also have that FTT policy. That 8 gigs now becomes 16 gigs. And you can imagine if you have 10,000 or maybe 20,000 virtual machines with a lot of memory, it becomes rather expensive. So what we introduced in vSAN 6.2 from the top of my head is an advanced option that will allow you to create thin swap files. So the big benefit, of course, capacity savings. You don't need to store those 16 gigs anymore. You have a thin swap file. Now, there's one downside. If you don't have the capacity available from a storage perspective and your virtual machine tries to access those particular blocks and it can't actually get those blocks, this is what you will end up see happening, right? The virtual machine will be stunned if you're lucky. If you're unlucky, it will just completely fail. The VMX process will fail. So only use this advanced setting if you have plenty of memory available in your environment.
Cool. Yeah, so just out of curiosity, are many of you running hybrid vSAN? Okay, and the rest of you running all flash? Okay, so what we're going to talk about here is applying policies on the fly. So, I mean, I'm guilty of it. I'm sure Duncan is guilty of it. But it was one of the things we said, oh, wow, this is really cool because you can change the policy of a virtual machine on the fly. And, you know, that's a wonderful thing. And it's nice to be able to do it. Very simple to be able to do it as well. But what we want to highlight to you here are some considerations about doing that, of changing those policies of your virtual machines on the fly. Okay? So we said, yeah, it's very easy to do. You can do it in lots of places. You can do it on a per VM basis, on a per VMDK basis, and you can also select a whole bunch of virtual machines and apply a new policy at the same time as well. And actually, when you change a policy on the fly, it tells you, hey, you can now change these policies directly, or you can wait to apply it later. And so, you know, the choice is yours. And so once we go through this part of the presentation, it'll give you something else to think about if you're doing those policy changes. Okay. So the first thing is changing FTT. So we're talking about a RAID 1 configuration here. And so we typically would start off with the default policy, which is failures to tolerate set to 1. So what if I want to change that up to 2 or even up to 3? Well, it's quite straightforward. What we do is we implement a new component and we just attach that component to the RAID tree and allow it to synchronize up. So that is pretty straightforward. It doesn't really impact the object that already exists. It's just appending onto the already existing object. Now, if you're going to do a change for the RAID configuration, I mean, if you're going to go from a RAID 1 to a RAID 5 or a RAID 5 to a RAID 6 or RAID 6 to RAID 1, well, that's a completely different story. Because what we do in that case is we instantiate a brand new object with this new layout. We synchronize the old object to the new object that we've just created, and then we discard the old object. So there's quite a bit of work that goes on in the background. There's a rebuilding, there's resynchronization and so on that has to take place if you're going to change the RAID policy. All right, so just keep that in mind. So what about doing something like changing the stripe width? So we've talked about stripe width already, where you can actually stripe your VMDK across multiple physical devices. And what if I want to increase the stripe width, going from 1 to 2, 2 to 3, 3 to 4, and actually we can go all the way up to 12 with a stripe width. it's the same as I've just described for the change in RAID configurations. We don't just put on a new stripe. We can't just, append a stripe like that because we already have existing data that needs to get striped across the new stripe width. So again, in this case, what we'll do is we'll create a new object with the stripe width that you've requested. We'll synchronize your original object against the new object, and then we'll throw away the old one once the resynchronization has completed. So the thing to bear in mind is, yeah, that might be okay to do on like a one-off or, apply it to a few VM decays or a few VMs. But you do something like this to 50, 100 virtual machines, change the stripe width on the fly like that. There's a lot of rebuild activity has to take place and a lot of resynchronization has to take place to synchronize the old object to the new object. So this is why we're highlighting this, because yes, we've marketed it as a nice thing to be able to do based on the requirements of your VM, but there is a consideration at the back end on what's happening and how much more activity you're going to get vSAN to do just to change that policy on the fly. So RAID protection, I've kind of covered this. Absolutely, if you're going to change the RAID configuration, it's instantiating the new RAID object, synchronizing to the old RAID object, and then we discard the old one when that synchronization is complete. So I've kind of broken it down here again. I don't expect you to learn all of this off, but some of these I've covered already, but there's a couple of peculiar ones that I wanted to highlight. So there is a policy setting for hybrid configurations, which is why I asked that question earlier. And this is the ability to set a read cache reservation. If you have a read cache reservation associated with an object, and you go ahead and you change the failures to tolerate in that case, it's instantiating a new configuration. Okay? So it's not the append configuration or the append process that I spoke to about earlier. It's actually going to create a new object, do the synchronization, and then throw away the old one. So that's a bit of a nuance to what I mentioned previously. The other ones that might seem a bit strange is the object space reservation. So object space reservation is basically how we do thickness of virtual machine disk files on vSAN. On vSAN, everything is provisioned as thin by default, and we get thickness using this OSR, or object space reservation. If you increase the object space reservation on the fly, so in other words, you have a policy with a 5% reservation and you want to go to 10%, you build a new policy and you apply that to a VM, it's again going to instantiate a new object, rebuild or resynchronize, and then discard the old one. So again, probably not such a big deal if you're just doing a one-off, but if you're going to apply this to tens or hundreds of VMs, there's going to be a lot of activity in the background for something like that. And then the final one, if you are doing increasing of the read cache reservation, again, this is for the hybrids, then there's one of these new instantiations of an object, resynchronization of old to new, and then discarding of the old. So it's not just a little change that we're doing when we're changing policies like that, but it can have a major impact at the back end.
Yeah, and we actually have had a lot of customers doing this. So they would change it for 1,000 VMs. For whatever reason, a lot of customers tend to forget that you can also create a new policy. So when you go through the exercise, create a new policy, apply it to a single VM, test it out first, and then start looking at the rest of the environments. The other thing that I wanted to talk about is the health check. We already have a bunch of customers here, so I'm pretty sure that every single customer has looked at the health check. Personally, I think it's one of the coolest features that we have, and it's not really, it's not actually storage related. We released it in vSAN 6.0, and before we had this, we had a lot of command line options. We have a lot of smart developers in our teams, and they create a lot of cool command line tools. Things like RVC, there's ESX CLI, you name it. And those are awesome solutions when you're a developer, right? But I prefer to spend most of my time in vCenter, hopefully the HTML5 client in the near future, either that or the web client as it stands today. But that's where I spend most of my time. So I'd like to see all of the issues that I potentially have in my environment in the web client itself as well. And that's why we introduced the host or the health check in the web client. So what does it do? Well, basically it tests your environment. It looks at your environment if there's anything wrong in particular with your environment. If there's something wrong from a latency perspective, if a disk is behaving strangely, if a disk is dying or a disk has disappeared or a host has disappeared, all of those different things will bubble up in the health check. Now, what a lot of people don't seem to realize is that this health check system is actually a weighted system. So in this particular case, you see a screenshot down at the bottom. In this case, what we did is we partitioned a stretched cluster environment. Now, if you end up in a situation like this, because it's a weighted solution, always look at the top one first, because if you solve the top problem, chances are pretty significant that all of the other issues mentioned on the list will automatically be solved after that. So if you've solved the top problem, you click retest, and then hopefully the other issues will also be disappearing. The other thing that we've noticed is that there are a bunch of customers that have 2 or 3 different tests failing constantly. In some cases, for instance, because they have an MTU set to 1496, and the vSAN does a standard ping test with an MTU of 1500. So in that case, that particular ping test also fails. If you're one of those customers, you're actually able to disable those particular tests. So you go to RVC, you disable that particular test, and the reason you should be doing this is because what we notice is that in the case of customers that are in the situation of having those tests constantly failing, the same test constantly failing, they stop looking at this particular screen. But at some point in time, other things are going to fail as well. And guess what? You won't be looking at the screen anymore because you're used to that red exclamation mark or that red X. So if you have one of those situations, use RVC to disable that particular test. There's a couple of other things that are more or less part of the health check. I don't know if people are already using vSAN 6.6, but we introduced vSAN Configuration Assistant as part of vSAN 6.6. Now, it has some really cool things in there, things like how to enable and configure HA in DRS, which is cool, but I'm pretty sure that most of you folks know how to enable HA in DRS. What is really cool about it is this part, right? As soon as you start using vSAN 6.6, what you can now go about doing is actually updating the firmware of your disk controllers using the web client itself. So you don't need to use some of the different tooling that the vendors provide. And I've used various types of them, and I can tell you not all of them work too well. So vSAN actually has that solution built in right now. And I can tell you in the near future, we'll actually have some of that included within the web client, within Update Manager. There's going to be a session by Christian Dickman, and I'm guessing that's one of those things that he's going to be showing. Don't tell him that I told you guys this already, right? Because he is coming out with a big surprise. So. The other thing that we have, and that's part of vSAN 6.6.1, it's getting complicated now with these release numbers, I know. The next one is going to be vSAN 6.6.6, number of the beast. I'm hoping it's not going to be that bad, but we'll see. But the other thing that we released is the cloud-connected performance diagnostics. We have a lot of customers doing benchmarks. So, they get a new shiny all-flash vSAN setup. They've got a lot of cool NVMe devices and they want to test these vSAN setups out. So they start running these different benchmarks, hopefully using something like HCI Bench or potentially the proactive tests that are part of the vSAN UI and part of the health check. And then what? You see these numbers. You see 50,000 IOPS and 3 milliseconds latency. What does it mean? Is it good? Is it bad? How do I improve it? Well, that's why we actually introduced this new feature. So this feature looks at the particular benchmark that you ran, and you can actually select it from the drop-down. So if you use HCI Bench or you use the proactive tests, you can select the benchmark that you ran. We'll be feeding the data up to our cloud. We'll analyze the data for you, and we'll provide you the results of what you can improve in your environment to actually hit the goals for your particular benchmark. So you select what the goal was, max IOPS or low latency or whatever it is, and we'll tell you what you should be changing. In some cases, you may need to increase the number of devices within the host, for instance, or the number of hosts within your cluster, or potentially, for instance, also change the benchmark. You may have picked the wrong block size, right? You picked a large block size or a small block size, and depending on what you've picked, we'll inform you about some of the changes that you need to make. So this is one of those things which I think was very useful in vSAN 6.6.1, and it's based on our phone home project. So we'll pull all the data in our phone home project and then provide you the results.
Good. Yeah, and I think with that, there's long-term plans will be to do a lot more than just look at, benchmarking. I think the idea will be to look at performance in general while vSAN is in production and give you some guidance as well at some point. So this is quite a quick section, really. It's just some of the troubleshooting options that you mightn't be aware of. So just really to run through the first one here. Okay, so, you might laugh, but you'd be surprised how many times a customer has gone ahead and rebooted a host, in the hope of addressing a situation that they were currently experiencing. And invariably, a lot of the situations that, arise around this are due to performance issues or due to, the cluster is not responding, or it's under some sort of congestion or some sort of saturation that's taking place. Invariably, if you're going to reboot a host in a situation like that, you're just going to make matters worse because you've now reduced the amount of resources that are available to the cluster. So I just wanted to highlight this. Don't reboot hosts. It's, when we're dealing with vSAN, it's not just ESXi. There's a whole bunch of other stuff that's going on as well.
Should we ask everyone to repeat that?
There you go. Okay, so onto the CLI tools. So we have a bunch of CLI tools available. ESX CLI, I'm sure you know about. There's a whole vSAN namespace there that you can look at networking, cluster, devices, and so on. RVC, you know about the Ruby vSphere console. This is shipping with your vCenter server, and it's basically giving you, where ESX CLI sort of gives you a host-centric view, we've typically been using RVC to give us a cluster-wide view of what's going on with vSAN. Power CLI continues to develop vSAN commandlets with every release. So for those of you who do Power CLI scripting and so on, there's always new commandlets coming in there. So check that out for sure. Now the next two you may or may not be aware of, but they're typically used by GSS when you're troubleshooting. CMMDS tool, it's very powerful. CMMDS is short for the Cluster Management and Monitoring plus Directory Services, or something like that, I think. But it's basically a way of querying the whole configuration of vSAN. Now, the problem with that is some of the configuration information that it returns is a little bit obscure, to say the least. So you need to know about UUIDs and being able to relate different UUIDs back to hosts, back to devices, and so on. The Python script, the fifth one in that list there, that's similar to CMMDS tool, but it decodes all of the UUIDs. So it'll give you the host name, it'll give you the device names, and so on. And so this is a kind of even more useful than the CMMDS tool. But the thing is, these two are primarily, I would say, GSS tools. The other thing is, eventually RVC will go away. I know we've still looked at some commands, and we continue to kind of add commands every now and then. But eventually the long-term goal will be to deprecate RVC. So for that reason, we're finding more and more functionality is being put into the ESX CLI. And the 6.6 release is no different. There's a bunch of new ESX CLIs there now as well. So there's actually a new interesting namespace here. This is the list of all the namespaces, but the debug one is quite interesting. And we looked at that already when Duncan showed you the votes associated with each component earlier on. But let's have a look at a couple more of those. So typically to get the limits, before this was available, we would have to go into RVC and run some RVC commands to get the limits. But now we have these ESX CLI debug options that will give us the limits as well. So you can see we're looking at the number of components per host, disk space that's used, the read cache, that's again only applicable to hybrids. We don't have read cache in all flash configurations. But you can see we can now get this information on a per host basis. Another interesting one is to do with driver versions that we can get off the different controllers that are installed on the host. It'll actually even tell you whether the controller is being used by vSAN or not. And so you can see here what I've done is I've got a truncated list here. The first controller is just the local controller. We're not using that for vSAN. You can see it's set to false. But the PERC H730, you can see there, that's the one we're using for vSAN, and it's giving you the driver version, the driver name, and also information like queue depth and stuff. So we're continuing to add a lot more into the ESX CLI namespaces for vSAN to give you everything that you need without having to go to RVC. So I'm going to do the next.
And of course, when you've been debugging, typically what ends up happening is that something has happened to your host. So the question is then, okay, what do I do? What do I need to do when, for instance, a disk has failed? Well, within vSAN, it's fairly straightforward. If you look at vSAN itself, as soon as something has gone wrong, what you will end up seeing is two different states in which a component can reside. So the first one is degraded. And degraded is probably, the best situation to be in out of the two worst situations to be in. Because with degraded, vSAN actually knows and vSphere actually understand what has happened to that particular device. So it's very similar to a permanent device loss in a traditional storage environment. In that particular case, what will happen is vSAN will recognize that that particular disk or SSD has failed, and we will start rebuilding the components that were impacted by that particular failure instantly, because we know that disk is not going to return. Now, the other option is, of course, that you've rebooted the host. You're doing troubleshooting, you figured, hey, it's a great idea to reboot the host, something has gone wrong, and in that particular case, vSAN doesn't know what happened. The host just disappeared. Could also be another reason, right? The networking guy. Are there any networking guys in the room? Only two. We can take them on. That's fine. So just imagine the networking guy creates a partition or an isolation, right? In that particular case, the host also disappears, but vSphere doesn't know what has happened because the networking guy hasn't informed you. So in that particular case, we will mark the component as absent, and we're not going to rebuild it instantly. Why? Well, we don't want to start that resync traffic, that rebuild traffic, when the host or that particular group of hosts may return anytime soon. So in that particular situation, we're going to wait for 60 minutes. Now, just imagine the networking guy is doing some reconfiguration of the Cisco switches or Arista, whatever they have, and they know it's going to take 4 hours. In that particular case, you don't want to wait for 60 minutes. You can also go to the UI itself, you go to the health check, and you can click repair objects immediately. So if that situation happens, you click that button at the back end, vSAN will start repairing those components, will start creating new components for those particular VMs that were impacted in that particular case. Now, in some situations, customers may want to shorten the amount of time that it takes for the rebuild to start as well. In some cases, customers have hosts that potentially reboot in 10 or 15 minutes, and they say, you know what, 30 minutes is long enough for me. And if you want to do that, you can actually change this advanced setting. So there's an advanced setting called vSAN clone repair delay, and that determines how long we wait for the restart to start, or for the resync to start happening. You can also, of course, increase it. You can also set it to 2 hours or 3 hours, depending on how long it takes for that physical host to restart. But that's one of the options you have. Now, of course, there are different type of scenarios when it comes to a disk failure. We've just asked, if there were any hybrid customers in the room, and if there were any all-flash customers in the room, and was probably a 50-50 mix. And there are different types of failures when it comes to it. So if you have a hybrid solution, well, in that particular case, deduplication and compression will always be disabled. And if a capacity device fails, that particular capacity device will be unmounted or dismounted, and the rest of the disk group will stay online. So only the components that are part of that are stored on top of that particular device will be impacted, right? If the cache device, however, fails, the cache device sits in front of the whole disk group, right? So if there are 7 capacity devices sitting under that cache device, then the whole disk group will be impacted. This is very similar to when you have deduplication and compression enabled. If you have an all-flash environment, you have deduplication and compression enabled, and one of the capacity devices fails, that whole disk group is impacted. So from a design perspective, that's something you need to take into account. A lot of customers ask why that is. Well, the reason is fairly simple. All of the metadata for vSAN itself is spread across those capacity devices. So if the capacity device is impacted, the metadata is inaccessible, which also renders all of the components on top of that particular disk group inaccessible. Now, if a situation like that occurs, hopefully we've already detected it beforehand. With vSAN, we have this smartness built in, which is called DDH. It used to be called dying device handling, I think.
Yes.
But sounded kind of negative, so we changed that to degraded device handling. It's still the same thing. Something is dying in your environment. It's probably not good, so you may want to replace that. So we have logic built in that actually looks at the performance degradation of your devices And if we start seeing a significant performance degradation for any of your environments, we'll start marking those devices as potentially dying in the near future. So at that point in time, you will see an exclamation mark in the UI. You can replace those devices before they die, and hopefully before you replace them, you place them into maintenance mode. Don't reboot the host or shut down the host. No, you place the device into maintenance mode, or you place the host into maintenance mode. Now, when you do place the host into maintenance mode, or when you do place the device into maintenance mode, or even the disk group, we will inform you what the impact is of what you're about to do, right? You can imagine that if you have an environment with 50 terabytes per host, that you may need to move a lot of data around. So we will tell you how much data will need to be moved, and if you don't want to move the data, what the impact is of making that decision, because it may render some of the virtual machines inaccessible. If you have only one copy of the data available at that particular point in time, then you will need to move it, because otherwise the data will become inaccessible. And last but not least, if you have deduplication and compression enabled, you can only place that particular disk group into maintenance mode, not a particular disk. So that's something to know for those already running an all-flash environment.
Cool, thanks. Okay, so you might be aware in 6.6, we moved away from using multicast to unicast.
Woohoo!
Yeah.
No one?
Pause here. So this is, there are some considerations, again, we wanted to call out. I mean, the whole idea of this session is to give you some background knowledge and some considerations and thoughts about what does that mean for you when we move from multicast to unicast. So that's the purpose of this particular one. So we've heard it for the last 3 years. Why are you using multicast? It makes things more complicated. We've got to set up IGMP queries or snooping or whatever you want to call it. So it involves getting the networking guys to do stuff on the switches. And this becomes even more complicated then if we want to route the vSAN traffic, especially in the case of stretch clusters or whatever, and that needs to go over L3. Then we need something that's going to carry our L3 or route or multicast traffic over the network as well. Typically, you're using a protocol like PIM to do that. So there was a lot of complexity about that, and we heard it from you guys about, can we make things simpler from a networking perspective? So yeah, we finally went to unicast. So what does that mean then? So when we had multicast, we had the IGMP for managing the group of nodes that are in that group, and they could all communicate to each other and so on. So now, if we have unicast, we no longer have that mechanism. So what happens in this particular case? So the vCenter becomes the source of truth now for cluster membership. Who's joining the cluster? Who's leaving the cluster? Is it a witness node? Is it a data node? And so on. All of that information now is held by vCenter. Okay? So that puts a little bit more responsibility on vCenter for tracking things, but that's fine. It's the one other thing I suppose that you would ask in this particular case is what happens if we lost vCenter? Well, we do actually track changes in the cluster on the host themselves. So if vCenter is out of the configuration for whatever reason and it rejoins the configuration, it looks at its sequence number of what changes have I got in the cluster and whether anything has changed as well. So I suppose the point I'm trying to make is that even if vCenter is out of the cluster, it shouldn't matter. You can still do manual changes and vCenter will just pick up those changes when it rejoins the cluster later. So when we form a cluster, obviously there's membership will need to be found. If we're adding or removing nodes to the cluster, membership needs to be updated as well. And then if you do something like an IP address change for the VM kernel interface that manages the vSAN traffic, it'll trigger a change as well. So that's the big difference. We're no longer using IGMP, that group management protocol for figuring out who's a member of the cluster. vCenter now has that responsibility. So we have another table, and this is really to do with upgrades. And so if we're going from a 6.2 configuration or a 6.5 configuration, and we're upgrading to 6.6, and this is vSAN I'm talking about now, when the last node in the cluster is at vSAN 6.6, the cluster will automatically switch from multicast to unicast. So there's no configuration setting that you need to do. There's no switch that you need to toggle or anything like that. As soon as all the nodes in the cluster are running 6.6, it's going to switch to unicast. But there is another consideration now, and that's to do with the on-disk format. So let's say that we have upgraded all the nodes to 6.6, and then we do the on-disk format and we bring everything up to on-disk format version 5, which is the latest. That cluster is only ever going to run unicast. That's it. It'll never go back to using multicast. So if you add older nodes to this cluster, be they 6.2 or 6.5, they can't talk unicast. They can only talk multicast. Those will be partitioned from the vSAN cluster. So bear that in mind. You cannot add older nodes. However, if I brought all the nodes up to 6.6 and I have left the on-disk format at, say, version 3, which is the previous version, and so all of those nodes are now running unicast because they're all running 6.6, and now I bring an older 6.5 or an older 6.2 node into that cluster, the cluster reverts back to multicast. So it's just a behavior that allows us to do the upgrade where we have mixed mode or mixed nodes, some of them running 6.6, some of them running 6.5 or 6.2. They'll continue to talk multicast. But the point is, as soon as I've done the on-disk format to version 5, you're going to only ever talk unicast from that point onwards. Okay?
Yes, we are nearing into the end.
Yeah.
So monitoring and logging. I've already mentioned the health check. And the health check is a great solution, but it tells you what's happening to your environment right now. You can click retest. You can actually go to the event section, actually see what has happened in the past, but it's not really a monitoring solution by itself. We have a lot of different options. We have the web client, has a lot of details. We have things like the vSAN DevOps, and I'll explain what that is in a second. But we also have tools like, for instance, SexyGraph. I don't know if people have seen SexyGraph ever or know SexyGraph, but it's a cool monitoring solution which is available for free, which is built by a couple of guys in France by themselves in their spare time, just because they like vSphere and I think vSAN is cool. So check that out if you haven't checked it out yet. So I just mentioned the VOPS, the VM kernel observation. It's one of those things that I don't think a lot of people know about it, but it's actually pretty cool. I started looking into it a couple of months ago. I'd seen William Lamb blogging about it a couple of times, but I hadn't used it. I have a lab, but it's not a production environment, so why would I set them up? But if you go to the event.vmessage file, we actually have a whole long list of thousands of different events that can occur in your environment. Those could be vSAN related, but for instance, they could also be HA related or network card related. So if there's an HA event, there's also a VOP, a VM kernel observation for that. So you go to this particular file and you look up all of the different events that can happen. And for the important ones, what you can do is you can create a custom alarm. So you create an alarm, which is just in the web client itself, and you copy and paste that particular event into the alarm itself. And now when this event occurs and it ends up in the VOPD.log file, an event will also be triggered in vCenter. So if, for instance, an HA failover has occurred, you would like to know about it, you can create an alarm for that, and it will show up within the vCenter interface. The other thing that we recently introduced was advanced VROps integration. Is anyone using VROps? Quite a number of people. So hopefully those that are also using vSAN have looked at the management pack. We started introducing the integration, I think, a year and a half ago, but it's pretty basic. We were showing more or less, what was happening on the host level, but we weren't showing a lot of statistics from a clustering perspective. So we had a long conversation with the VROps team, and what they started creating is these new dashboards. And these dashboards actually show you across the board, how your environment is doing, not just for one cluster, but for 5 or 10 or 20. Right? It shows you, for instance, what the average latency is, how many IOPS your environment is serving, those types of information. Now, this is pretty cool, but what's even cooler than that, in my opinion, is Log Insight. Log Insight seems to be one of those utilities that a lot of people tend to forget about, but it has a lot of value from my perspective. Login site is a syslogging system. So if you're not using a syslog system yet, I encourage you to look at login site. And it shows you a lot of details for vSAN because we created the vSAN content pack for login site itself. So it will show you things like, if components are degraded, if liveness is lost for a particular host, so we don't know what has happened to a particular host, we can't ping them or whatever it is, right? And based on that, what you can start doing is try to figure out what has happened in your environment. If the networking guy has created an isolation or partition, you can actually use login site to figure out what the impact was on multiple hosts. Not only on multiple hosts by looking at the standard dashboards that we have, but there's also something like an interactive widget. So within login site, there's an interactive widget, and you can start creating your own queries. You can use one of the default queries that's available in the interface itself, and then you start editing it based on what you're looking for. Not only for that particular host, but across hosts. And that's the great thing about something like a syslog server, because in most cases when an issue arises, it's not one host that's impacted, but it's usually multiple hosts, potentially something within VC, which also all of the data is pulled into to login site itself, and potentially it could be something else, like the network or whatever it is. So you look at login site or any other solution, and you start creating these correlations between the events that have occurred. Now, if an event occurred, this is probably one of those things that you will typically end up seeing, and that's what Cormac is going to end the session with.
Yeah. So congestion, how many of you have come across congestion? Yeah, quite a few of you. Okay.
Too many, I would say.
Indeed, indeed. So what we're going to try and do is just give you an overview of what congestion actually is and what are the most popular causes. And I know we're kind of getting close. I'm not going to go through this. This is just an architectural overview. But the one part of the architecture that we're interested in here, and let me click down through these, is the LSOM. It's the Log Structured Object Manager. It's basically what takes care of the I/O to physical disk. Okay, be that to the capacity or caching tier. So just to break down what LSOM is and where congestion can occur, when we do I/O to our physical disk layer, there's obviously the caching tier and there's the capacity tier. For the caching tier, we have what's called a logical log associated with it. Okay, and this is in the case of crashes or whatever, to be able to know what we intended to write to disk and whether it made it to disk and so on. Now, in the logical log, as I said, we have that for the caching tier, but we have another component called a physical log for the capacity tier. And in these areas, this is where congestion can arise. So when the system is under stress, when there's bottlenecks or whatever is taking place, we introduce this artificial congestion as a sort of throttling mechanism to slow the system down so that it can behave or balance itself, if that makes sense. So we have the L-log congestion, which is associated with the logical log, which is associated with the caching tier. And then we have the physical log congestion, which is associated with the physical log, and that's associated with the capacity tier. Where we would see L-log congestion is when we have virtual machines doing lots of I/O, and we have to get that into the caching tier. Where we would typically see P-log congestions is when we're trying to destage out of the caching tier into the capacity tier. Does that make sense? Okay, so just what can cause this? Well, obviously the net result of congestion is, higher latency, essentially. So what can cause these congestions? An overloaded system, for one. So this is why the benchmarking tool is very useful. Duncan mentioned that, the performance diagnostics, to look at benchmarks to make sure that you're doing everything right. That can be very useful. And then, of course, insufficient resources. So I don't have enough caching devices, or I don't have enough cache, I don't have enough disk groups, I don't have enough hosts, or whatever the case may be. Network errors are another common cause of congestion as well. So, everything is going great on this particular host, but actually when I'm doing the I/O across the network to another host, things aren't going so good for whatever reason. So now I have to introduce congestion on this host to kind of balance the I/O that's going to the two different components on the different hosts. hands up, we could have actually issues in vSAN as well. And we have had issues in vSAN software that's led to congestion issues. And there is, I put the version numbers in there. You should be running something like 6.0 patch 04 at a minimum, or if you're in 6.5, the Express patch 02 as a minimum as well. So that addresses some of those issues that we've had with congestion in the software also. And then finally, this is a kind of obscure one, but I thought I'd put it in here as well. There's some BIOS settings that could lead to CPU contention, which had a knock-on effect to cause congestion as well. So with 16 seconds left, I think we're pretty much done. So we are going to hang around for a while. We'll take questions. I know the time is up, so thank you very much. I hope you found it useful.